Hello, welcome to Maths. Today I want to describe about the congruence and congruence principles in properties. Okay, what is congruence? Definition is if m is a positive integer and m is not equal to 0, a and b are said to be congruent modulo m if there exists an integer k such that a equal to b plus km. Okay, in other way, a minus b is divisible by m. Okay, then we can say A and B are incongruent modulo M. Also means B is the remainder when A is divided by M. Okay, this is represented as A congruent B modulo M or mod M. Okay, examples. 2023 when divided by 5 gives you 3 reminders. So 2023 is congruent to 3 modulo 5. 1947 when divided by 10 gives you 7 remainder. So 1947 is congruent to 7 modulo 10. I hope this is clear and understood. Let's learn the properties of congruence, which are useful to solve several problems. Okay, first property. If A is congruent to B modulo M, then B is also congruent to modulo M. This is very easy to understand. Just a simple proof. It is given that A is congruent to B modulo M. That means A minus B is divisible by M. That means B minus A is also divisible by M. So you can put B is congruent to A modulo M. Simple. Property 2. If A is congruent to B modulo M and B is congruent to C modulo M, then A is congruent to C modulo M. Okay, let's see. See the proof. It is given that A is congruent to B and B is congruent to C, both are modulo M, which means A minus B is divisible by M, B minus C is divisible by M. Okay, from above two statements, we can derive A minus B plus B minus C also divisible by M. Okay, which means if you add them A minus B plus B minus C, the result is A minus C is divisible by M. That is, A is congruent to C modulo M. Example given here is 123 is congruent to 23 modulo 10 and 23 is congruent to 3 modulo 10. Then we can say 123 is congruent to 3 modulo 10. Okay. If you apply it back, 123 minus 23 is 100 divided by 10. 23 minus 3 is 20 divided by 10. So 123 minus 3 is 120 divided by 10. That's what you have to make it. Now let's see property 3. If A is congruent to B modulo M and C is congruent to D modulo M, then A plus B is congruent to C plus D modulo M. Let's see how this is possible. Okay. The given information is A equal to B plus XM. Okay. C equal to D plus XM. Okay. X and Y are some integers. Adding above two equations will get A plus C equal to B plus D plus X plus 5 into M. Here X plus 5 is just another integer. So you can always say A plus B is congruent to C plus D modulo M. Okay. Look at the example. 14 congruent to 2 modulo 3. Okay. And 10 is equal to 1 modulo 3. And if you sum up 10 plus 14, that is 24, is congruent to 2 plus 1 3 modulo 3. And the 3 modulo 3 means it is 0 basically. 0 modulo 3. Okay, let's go. Let's see the property 4. This is most important. Most of the remainder theory problems are solved with property 3 and property 4. So check this carefully. If A is congruent to B modulo M and C is congruent to D modulo M, then AB is congruent to CD modulo M. Let's see the proof here. Given information is A equal to B plus XM, C equal to D plus YM. X and Y are integers. Multiplying above two equations, you will get AC equal to B plus XM into, sorry, this is into B plus XM into D plus YM, which is equal to B plus D plus BYM plus DXM plus XYM square. Now rearrange these numbers. AC equal to BD plus BY plus DX plus XYM whole into M. Here if you see BY plus dx plus xym is just an integer. So you can always say BD equal to congruent to CD modulo M. Example, 14 is congruent to 2 modulo 3, 10 is congruent to 1 modulo 3, so 140, 14 into 10 is 140 is congruent to 2 modulo 2 is, how did you get to 2 into 1, that is 2, 2 modulo 3, okay. So these are the properties of congruence which you can apply in solving the problems. What kind of problems you can solve? Just I will give you a few examples here, but for more information you can check my previous videos. Okay, last digit and last two digits of a given number. Okay, here I took the example as 2201 to the power of 2000. So the number looks too big, so we can't just go by multiplication and all. So how we solve this is basically last digit of any number n is n modulo 10. Okay, last two digits are n modulo 100. So we use this property and solve the problems. So 2201 is congruent to 1 modulo 10. Okay, now 2201 to the power of 2000 is also 1 to the power of 2000 modulo 10. How did we get this? Okay, this is the property 4 of congruence. You can check the previous slide. Okay. Then 2001 to the power of 2000 is congruent to 1 modulo 10. That means the remainder is 1 when this number 2201 to the power of 2000 is divided by 10. That is the last digit. Okay, same way we can do it for last two digits. That is 2201 is congruent to 1 modulo 100. So 2201 to the power of 2000 also 1 to the power of 2000 modulo 100. Okay. Which means it is remainder is 1. So the last two digits are 0, 1. Okay, this is one type of problem which you can solve with this. Other type of problem is sum of digits of 2423 power 10. Okay, you add the digits of this number until you get a single digit. Okay, example I am giving here. Sum of digits of 7747 is 7 plus 7 plus 7 plus 7, that is equal to 28. Then 2 plus 8, which is 10. 10 is 1 plus 0, which is 1. So 1 is the uh, answer that I am expecting when 7777 number is given. So similarly, I want the sum of the digits of 2423 power 10. Okay. Now, if you look at the problem, it looks how it is related to remainder theory, but it's very easy. The number 9 has a property basically. You divide any number with 9, you divide any number with 9 basically, the remainder you get, okay, the remainder r is the remainder. If r is the remainder when a number is divided by 9, then r is the remainder of the sum of the digits of that number also, okay, and r is also sum of the digits of that number. Okay, if r is 0, that means sum of digits is 9. Okay, otherwise 1 2 3 4 5 6 7 8, yeah, it is equal to the sum of the digits of that number. So once you know this information, solution is very easy. You just need to find out mod 9. So 2423, if you take mod 9, you know it is 2. You divide 2423, you'll get the remainder 2. So 2423 to the power of 10 also, 2 to the power of 10 modulo 9, which is 2 to the power of 10 is nothing but 1024. You can go ahead and divide and find the remainder, or you can also stop it here and just find the sum of the digits of 1024, that is 1 plus 0 plus 2 plus 4, that is 7. So 7 is the sum of the digits of 2423 power 10. Okay. So these are the types of problems you can solve. I just listed more types of problems which we can solve using remainder theorems. See the videos given in Olympiad Remainder Problems playlist in my channel at PSK 99999. Thank you.